Hi, I'm DSL Samson and I will be discussing the Digital Subscriber Line or DSL. So my report will be divided into families of DSL and broadband technologies. So what is a DSL? DSL or this Digital Subscriber Line is a telecommunications technology that is used for providing high-speed transmission to subscribers over the existing copper wire twisted pair local loop between the customer premises and the telco's central office. It was designed to provide high-speed data and video on-demand services to subscribers at speeds much faster than Integrated Services Digital Network or ISDN. DSL-based broadband provides transmission speeds ranging from several hundred kbps to millions of bits per second or Mbps. How a DSL works. So a DSL is a form of digital modern technology that works using an advanced signal processing and digital modulation techniques. However, with DSL, the digital signals are not converted to analog or vice versa. Instead, the signals remain digital for the complete communication path from the customer premises to the telco central office. So ADSL represents a family of related services or commonly known as XDSL. And here are the following: RADSL, ADSL, G-Lite, SDSL, HDSL, IDSL, VDSL, and VDSL2. So first, the RADSL or Rate Adaptive Digital Subscriber Line. It is the most robust business DSL available today, and it is developed to overcome line impediments. It automatically adjusts for environmental conditions because RADSL supports symmetric, or meaning equal downstream and upstream data transmissions up to 768K. Next is the Asymmetric Digital Subscriber Line or ADSL. It allocates line bandwidth asymmetrically with data speeds that can reach up to 7 Mbps downstream and 1.5 Mbps upstream, depending on the implementation. That is why an ADSL typically provides faster speed in the downstream direction than the upstream direction. ADSL can deliver simultaneous high-speed data and telephone service over the same line, as it does not disrupt regular telephone calls on the line, and at the same time, it provides a faster voice service. It is used primarily by residential customers, such as internet servers who receives a lot of data but do not send much. Next is the ADSL Lite or G-Lite. It is the lower speed version of ADSL, and it provides downstream speeds of up to 1 Mbps and upstream speeds of 512 kbps at a distance of 18,000 feet from the service provider premises. It is intended to simplify DSL installation at the user's end. And next is the Symmetric Digital Subscriber Line or SDSL. It supports symmetric or equal downstream and upstream data transmissions up to 1.54 Mbps. It is used typically by businesses for services such as video conferencing, which needs significant bandwidth both upstream and downstream. Next is the High Bit Rate Digital Subscriber Line or HDSL. It supports high-speed, full-duplex communication up to T1 or E2 speeds over multiple twisted pair lines. It provides a symmetric connection that is upstream speeds and downstream speeds, and that ranges from 1.544 Mbps to 2.048 Mbps at a distance of 12,000 to 15,000 feet. Next is the ISDN Digital Subscriber Line or IDSL. It provides up to 144 kbps transmission speeds at a distance of 18,000 feet. It can be extended with a repeater. So from the figure, This is a sample of a repeater or Wi-Fi repeater. Next is the very high bitrate digital subscriber line or VDSL. It is the fastest of all XDSL provider and provides a transmission rate of 13 to 52 Mbps downstream and 1.5 to 2.3 Mbps upstream over a single copper pair wire at short distances of 1,000 to 4,500 feet from the service provider's premises. And lastly is the very high bitrate digital subscriber line 2 or VDSL2. It is faster than VDSL and provides transmission rates up to 100 Mbps at longer distances. And together with the DSL, here are the other different broadband technologies available today. So these broadband technologies are categorized into wired broadband technologies and wireless broadband technologies. So for the wired broadband technologies are the copper wires, cable modem, broadband over power line or BPL, and optical fiber. While for the wireless broadband technologies, these are the antenna sites for wireless connections and satellite broadband. And so for the copper wires, it is defined as the legacy telephone unshielded copper twisted pair. It it provides broadband connections by using XDSL technologies such as ADSL or ADSL2 plus, FDSL or VDSL2 plus or VDSL2 negative, and also V plus or VDSL2 vectoring or G that fast. Next is the cable modem. Cable modem service enables cable operators to provide broadband using the same coaxial cables to deliver pictures and sound to your TV set. So, what is a coaxial cables? These cables consist of a copper core and a copper shielding coat. The TV cable networks are therefore much more efficient than the traditional telephone networks. So most cable modems are external devices that have two connections, one to the cable wall outlet and the other to a computer. They provide transmission speeds of 1.5 Mbps or more. Next is the broadband over power line or BPL. So broadband can be delivered over existing low and medium voltage electric power distribution networks. So BPL speeds are comparable to those of XDSL and coaxial cables. Next one is the optical fiber. So optical fiber lines consist of cables of glass fiber connected to end users' homes or FTTH, fiber connected to end users' buildings or FTTB, and or fiber connected to end users' street cabinets or FTTC. They allow for very high transmission rates of 100 Gbps and more within very wide 10 to 60 kilometers efficiency range. This is the most future-oriented solution but requires high investment in passive infrastructure. And for the wireless broadband technologies, these are one of which is the antenna sites for wireless connections. So it is provided by WiMAX, that is up to 60 km efficiency range, Wi-Fi where its efficiency range is 300 meters, and 4G or LTE Advanced, that is up to 3 to 6 km efficiency range. So further improvements will focus on new standards with additional features and provisions of additional frequency spectrums or 5G. The next one is the satellite broadband, or also referred to as Internet by satellite. It is a high-speed bidirectional internet connection that is established via communications satellite located in the stationary orbit. The end customer sends and receives data via satellite located on the rooftop of the house. And that's it. Thank you for listening on my reporting.